Hey guys, this is Moose from Team Extreme, DJ Moose on RC Groups and Flying Giants. I wanted to put together a quick video on how I program and gang Aileron servos with the Hitec Brushless Servos and the Jeti radio system. This is a wing from the Extreme Flight 105 Slick 580, and because of how well this is designed, this process works very well. So there's three things that come into play here. The whole basis of my strategy is to get the servo arms aligned with each other. And what that does is tells us that they are parallel to the hinge line. And that's because the servo pockets are equidistant from the hinge line in both areas. And what's even better is that the holes to mount the servos are already drilled, so there's no like play of a 16th here or there when you're actually mounting the servos. So that makes a big difference. So the fact of where the servo pockets are in this design, that tells us that if we align the servo arms, they will be parallel to the hinge line. Now, what makes it really work is the fact that you have different horns for the different aileron servos. The longer horn goes on the outboard, the shorter horn goes on the inboard. They're longer because the wing tapers, and so before you glue these, you should measure to make sure that the pivot point is the same distance down to the hinge line in both areas. I've had some manufacturers where you actually had to shim these horns a little bit to get it to match, because if they're off like by a 16th, it's really going to mess this up. But Extreme Flight did a great job. There's no shimming. These went in perfectly. Follow the instructions mounting the horns and you'll be fine. So I know the Extreme Flight book says to just set your arms at 90 degrees. You can see, this is the finished product. You can see they're very close, but I went ahead and just aligned them together. I think they're a little bit off than 90 degrees. That's my strategy. There's a bunch of different other ways to do this. Also in the video, I talk about setting the Jeti radio to get the same pulse width as what the Hitec programmer suggests or programs the servo to. And that magic number is plus and minus 124% in your EPA on the radio. Now in the radio, you see that I go a little bit higher for 130 for the max and set the limit to 124. That's because I'm on the DS14. It has plastic gimbals and you can kind of push. It's kind of weird. If you push further than the end, you get a little bit more throw. I'm not sure if that's the way it is on the 16 or the 24. I don't have either of those radios with the aluminum gimbals, but that's what I do to combat that little bump. So you might not need to do that, but just remember the magic number is 124 positive negative to get the 900 millisecond one endpoint and 2100 second other endpoint. The reason I like this strategy is because it allows me to run both of these servos on the same channel. They're both getting the same servo signal after they're programmed. So one channel, Aileron 1 channel goes to the left wing, Aileron 2 channel goes to the right wing. The servos are programmed. There's no trim whatsoever. You're getting full throw, and that's how it works out when you program like this. So if you're interested, let's follow along. There's 4 main steps. First is to align the arms. Second is to get your pushrod lengths. And then the third is to program this servo. Fourth is to program this servo. So let's begin. All right, guys, the first step to doing this is to, I know the instruction booklet says to set the servo arms 90 degrees to the servo case. So instead of doing that, what I do is I align the servo arms so they're perfectly in line with each other. So what I'm going to do is I'm going to take a straight edge across both of these servo arms and make sure they're perfectly aligned. And so basically how I start off is I have these 2 servos hooked up to my radio on different channels right now. And I take this long straight edge and basically put them up to the servos. And you can see very clearly they're not aligned right now. So what I'll do is just trim things out a little bit and go from there. Still a little more. That's getting there. That looks almost close right there. So now let's do the outboard one. Too far. Maybe one down. And this is why I like the SWB arms, because they're straight. Now, the Extreme Flight servo arms, while they're not perfectly straight, they have a straight piece on the bottom that you can use to align like this. All right, so we're pretty much there. And so you can see these servo arms are now perfectly aligned with each other. That means they should be perfectly parallel to the hinge line in both spaces. So that's the end of step one. Next step, we're going to put the rods on, and then we're going to create the rod length. All right, so what we've done now is we've connected the rods, hooked them up for good. This one we're leaving undone for right now, and what we're going to do is set the rod length for this inboard servo. So I've left my radio on. It's kept it where we set it, so these are still in line, and what we're just going to do is use the turnbuckle tool to shorten it up. All right, so that's where we want it, right there. So now we're going to do the same thing with the other one, but we are going to unhook this one and kind of do the same thing to the outboard. All right, so now that that's even, we've got that push rod length, the aileron is perfectly centered, and now if we reconnect this should easily thread into the servo arm, and sure enough it does. So now, what does that mean? It means that our push rod lengths are where we want them, and that's it. We never have to change the push rod lengths again. So the next step is actually going to be programming this servo. All right, the next step is to program this inboard servo. These are the Hitec 9380s brushless. To do that, I'm using the Hitec DPC-10 programmer with a USB connection to my laptop with the software on the screen in the laptop, and I have all this stuff plugged in behind my laptop. So I just have a little power switch here, an RC switch to turn the power to the servo. You'll see that light turn red and some blinking lights saying that it's loading. And then you hit connect on the software. Connected. All right, this is good. All right. So this is where, I don't want to go in too much, but you can set your soft start and your fail safe, and then you can manually test the servo. And so if you hit 1800 milliseconds, it goes 1200 so you could manually move it. But so right now what this is saying at 1500 milliseconds, that's where it's set to be centered. However, it's not quite where we want to be. So what I'm going to do is do an EPA reset. It's always good to do that when you're programming a servo, in case it's been programmed before or you're using it from another plane like I am. So I just want to kind of get the factory defaults. So we hit setting, and then we hit EPA reset. And that kind of just clears it out, and we'll write it. The write all button kind of just refreshes everything. So now we're ready to begin. Here's what I do. I will now go ahead and connect the surface. And so we can see that it's not center right now. So we're leaving the outboard unconnected. We're just programming this one. We didn't put the nut on the bottom of the servo arm because we're going to be taking this on and off a few times. So we go into the software and we click the setting thing. It says will begin setting for EPA center. So now it's in the setting mode, and we have this kind of bar here that we can move back and forth. So we'll start hitting one of these arrows, and that's the wrong direction. You see how every time I hit this, it's moving the servo, but it's moving in the wrong direction. So if you click in the bar, it goes down a bunch. And that was just a little bit too far, so now we'll do some fine-tune adjustments. And then that feels good. And then the other thing I do at this point before I do anything is I go back here, and that's off, so we can't check that because I turned the radio off. So now this is the center. So before we hit anything on there, we're going to unconnect this because the servo is going to move really fast. We don't want to break anything. So we've fixed our center. We know that's where the center wants to be. And we hit OK. And it says we'll begin setting up for EPA left. You'll see the servo move down. And we're going to do the same thing. We're going to reconnect to the arm. And this is the slightly hard part because on the down, when the aileron goes down, you kind of have to hold the wing up to judge the precise angle that you want. So I already have my angle meter set. I'm looking for 32 degrees on the aileron. This is not going to be for 3D. This is my IMAC plane, so 32 degrees is fine. So what I will do is kind of hold this up. And you know what? We might be able to get that down in there. Perfect. So now we have our angle meter here, and we see we have quite a bunch to go. So what I will do is go on the software and just keep hitting that arrow until we get to 32. Just a hair too far. Just another. I like that. All right, so that's 32 degrees up. So what I'll do is turn this over again. And like I did before, unconnect this. Now that's the hard direction. This other direction is easier. So now we have that set where we want. We want to hit OK. We'll begin setting up for EPA right. You'll see the servo move, and we will repeat the process. Where'd my angle go? So we go here, we see we have quite a bit much to go. So I'm going to hit in the bar to move it a little bit further. Boom. Probably, it's way too much. You can see now I'm moving at the very end of the bar so I can get really fine adjustments. Too far, we'll go back. That's it right there, 32 degrees. So, one last time we will unhook this. Because when we hit OK, it's going to swipe down the center. So we go here and say OK, completed. Now it's important, you'll see that go back to center. You always have to hit right all, because right now it's all kind of in memory, it's not actually written to the servo. You have to hit right all completed, and now the servo is completely programmed. And we'll go on to the next step, which is programming the outboard servo. All right, the next step is to program the outboard servo. This one's a little bit more complicated, but you'll see kind of my methodology and you'll see how it kind of works really well. First thing we want to do is check to make sure that this works well. I've plugged it back into the receiver. I'm going to turn the model on and it's centered. You can see there's some movement now, but it's centered, so the programming has taken. Mix that a little bit. So yep, so we're good. So the important thing here is that we have to kind of then sync our Jeti radio to the way the Hitec servos are programmed. So if you can see here, the end point is 900, midpoint is 1500, and the high point is 2100 milliseconds. So the reason this works really well with Jeti radios is because the Jeti radio centers exactly at 1500 milliseconds. So they match up really well. Now what we need to do is set the endpoints so the max travel is right around 2100 and the minimum travel is around 900. So what that equates to, I've troubleshot this a little bit and figured out the numbers. What you need to do is set your max. Let's see, I'll bring it up for you. I think we can see this here. You want to set your max and positive and max negative, sorry, try to get that light out of there, to 130 and minus 130. Now, the max positive and negative limits should be 124 and minus 124. Why is that, you ask? Well, So I do that because on the DS14 they have the plastic gimbals. So if anyone who has one of these knows that if you kind of get to the end, and if you push a little bit, you can get a little bit extra travel. And so I found that if you do the max and the limits, just like this, about 6 degrees more, you kind of miss out on that kind of bump, which kind of helps when you're programming the servos. So set up your travels like this, 130 and 124, plus and minus, and you're ready to go. So now we have this set up, and we're going to leave this on. So this servo is connected to the radio, and I'm going to set this down, and we're going to have the other servo plugged in to the programmer. And so I'm going to go over here, hit the power switch, and you heard the outboard servo connect, and you hit connect. And you see connected, good. So now what we're using is that the radio is still on. This is holding at exactly center. So we know that we want that arm to be where it lines up with this push rod perfectly. And let me move it out there a little bit. We want it to line up with this push rod perfectly because we know this is at center already. So what we'll do first, and we'll make sure this is connected here. You'll see down over there. Yep, it's talking to it just fine. So go to 1500. Like I said, we're going to reset, so hit setting. Hit EPA reset once. It kind of resets and goes back out. We're going to write it just to be safe. And now we're going to set it. So we're going to start again with center. Now it's up, asking for us to set it to center, and it's way high. So all we're going to do now is just move that down, and we're going to keep moving it down until I'm going to lay the horn on here. Move it down there a little bit, and keep moving until I see basically right cleared through the hole. A lot more, a little more. You can see as I'm hitting the button, the servo is moving. Need a little more. And at some point you'll see perfectly through. And the test is how smooth it is to thread in. You don't want any binding whatsoever. So the fact that this is going in really smooth tells me that it's good. So now we've set that center point, and because earlier we set the pushrod lengths, we know that these are still aligned, and that's how you can program them perfectly like that. So what I'm going to do is unhook this. I'm going to hit OK. It's going to go to the left and go down. So now what we do, we take our radio and we go all the way down, and you see that's holding that down. And what I'm going to do is turn off my radio.
Signal lost. Signal lost.
So now the radio's off, but the servo is still exactly where it's holding it right at 32 degrees. So now we're going to do the same thing. So now we go on here, and we'll see it moving the arm down every time I click the button. Need a little bit more throw. Quite a bit more, so I'm going to hit in the bar once. That's a little bit too much, so we'll go back a little bit. And you can hear each time I click the button, you hear the servo move. And I can tell that's right because when you look straight over top of it, you can see directly down And now we have that setting programmed for the outboard servo. So I will unhook this and hit OK. And it's going to go to the right. You'll see that move up. And we're going to go turn our radio back on. All right, so now it's back at center. Now we're going to go the other way. So I have it on. I'm going to put the stick all the way to the left in this case to get the aileron down or up, depending on which way you're talking about. And going to turn the radio off. Turn it off. Yes. Yes. So now the radio is turned off, but the servo is still held there right at 32 degrees, and we will go and program this direction of the outboard servo. It's quite a bit more. We'll do another one. Just a hair too much, so now we'll bring it back just a little bit in little increments. I think I want one more. And there it is, butter. Thread's nice and easy, it's not binding. And we know that's the end point. So now we'll unhook it. We'll hit OK on here. It's completed. That goes back to center. We're going to write it. Remember, it's really important to write. Write all completed. So that means that servo is now done. So I'll go back here. Turn off the power to the programmed servo. And plug it back in to the meter. There's the bolt. We'll go turn our radio back on. That will go down nice and slow. And now this should line up perfectly, which it does. And now both servos are programmed. And they're both programmed very closely, really closely as mechanically exact as possible. They're both on the same channel in the radio. So they're getting fed the same exact signal. And next I'm going to hook up the voltmeter to show you the kind of resistance we're getting. Alright guys, the final step is to check your current draw on both of the servos. So I have one of the Fromco voltmeters here, current meter. Still have everything hooked up just as I had it before, and I just kind of wanted to run through the range of motion to show you. I did nothing since the last time, since we programmed the last servo. No adjustments, no trim or anything. And if you see going through a slow range of motion both ways, we're not even getting 1/10 of an amp. We're talking like 50, 60, 70 milliamps. Now, we go a little bit quicker, we're going to get some higher numbers. There was 153, 138, 2 and 3 right there. But again, that's 0.2 amps. This is milliamps it's reading. It's getting like 300 milliamps, which is like 0.3 amps. So I'd say that's pretty good for gain servos. And they're running off the same channel. They're getting the same pulse width. Aileron 1 is going both to these two servos. Aileron 2 is going to the other two servos. And that's how I program the Hitec servos. So again, there are many different ways to do this. This is the way I do it. I found that the Hitec servos are able to be programmed very well with the Jeti radio. And so that's why I do this. I'm not saying it's the only way, but in case you guys wanted to see how I did it, how I programmed the servos with no trim. There's no trim on either of these channels. They're full throw both ways. That's how I get the full resolution I need, and that's how I go. So if you have any questions, again, I'm DJ Moose on Flying Giants and RC Groups. Let me know what you think, and if you see something I messed up, tell me something I should do better next time. So thanks, guys. We'll talk to you later.